understanding the XD security breach of open source security. Our speakers are Jarrod, Millman, who is the executive director of the newly formed UC Berkeley Open Source Program Office. And he's also the senior open source scientific Python developer at the Berkeley Institute for Data Science. His background, these are slowly coming, so if they won't hear the introduction, you know. All right. His background is in computer science, mathematics, and statistics with degrees from Cornell and Berkeley, and is founding member of the scientific Python ecosystem. His primary focus is on development sustainability of open source and community of scientific research. Now, Juanita Gomez is a PhD candidate here at UCSC, under the supervision of Alvaro Cardenas, and she's working specifically on a dissertation related to open source software security. She is an experienced programmer, mathematician, and open source advocate, former developer of Spider IDE at OnSite, and she's a community manager for the Scientific Python Project. Both Jarrod and Juanita are actually part of our UC network, specifically looking at doing specific work on open source security and software supply chain security as part of the work that we're doing under our SLIM grant, and that's what they're talking about. So I'll let them go.
Yeah, so it's appropriate that we're today on the beginning of the cybersecurity awareness month. October 1st, we're going to talk about this XD security incident, which we'll get back to that title or the naming of this incident in a moment. But first, Juanita's going to begin this keynote address by telling you, I guess, what the official story is.
Okay, so earlier this year, there was a major security incident. We call it the XD security breach, but we'll think about that later. It had a lot of media coverage. It was in the New York Times, and well, this is a screenshot of a couple of articles. So I'm just going to go a little bit about what we heard that happened. So this is a very, very famous image from the XKZD comic called Dependency, and it shows how the Wolf digital infrastructure looks like. It has been used to tell the story of the XC. So our whole infrastructure relies on systems where very close to the bottom, there's a thin block that supports the entire system. Most critical open source projects are maintained by volunteers, mainly for personal reasons. And if one of these blocks break, then the balance of the whole digital infrastructure can collapse. So this is exactly the case of the XC library. In this case, though, it was a person in Finland maintaining XD, which is a data compression library, which we would think it's not critical, but it could be used to access Linux systems. So what's the official story? On March 31st, we learned that a Microsoft developer found a backdoor that was intentionally planted in the XC utils library, which is an open source data compression library that is available on almost all installations of Linux and other Unix-like operating systems. So this backdoor was very, very close to getting merged into Debian and Red Hat, the most popular distributions. And it could have led to very widespread security breaches. How did we find out? So on the screen is an engineer at Microsoft, and he was benchmarking, and he realized that SSH processes were using way too much CPU. And by looking into that, he discovered that SSH connections were taking around half a second longer than they should. He did a big dive into this and discovered the backdoor, which was reported immediately. So in summary, we got lucky, very lucky. No one was looking for security. They were looking for pretty much the time. I'm going to read this for people in the back who cannot see. This is just a tweet close of someone in Twitter that was shared widely because it was very funny when this happened. So it says, So kids, what's the moral of the XC story? If you're going to backdoor something, make sure that your changes don't impact its performance. Nobody cares about security, but if your backdoor makes the thing half a single slower, some nerd is gonna dig it up. So this is exactly what happened. No one was looking for security issues at XC. They were just benchmarking, and we got very lucky with these engineer at Microsoft discovered this. So, is there more to this story?
Yeah, so like any good thoughtful American citizen, I looked at the mainstream media reporting and I decided I would do my own investigation on the internet. And I'm going to be reporting about that today. Certainly I think the story they told has some truth to it, but I don't believe it's all the story. And I'll talk a little bit about what I think they missed, why I think they missed it, and I think what the university and specifically perhaps the UC OSPO's role could be in telling the rest of the story. So one of the things we hear a lot about is maintainer burnout. And that's a real thing. I feel it myself. I maintain several open source projects, and I feel often underappreciated and overworked, over stressed, and it's something that's, I think, a real problem. But if you read a lot of these articles, like this was just one of them, but you can find this over and over again. In fact, this article refers to another article. And says maintainer burnout has been blamed for the XC incident. The maintainer reported feeling behind on it and eventually ceded responsibility to a user who introduced the backdoor of a software component. There have been long calls for the private sector to do more to support the FOSS ecosystem, but for the most part, those calls fall on deaf ears. So that last sentence I totally agree with, but maintainer burnout I don't believe was the problem, and I think it's a little bit cavalier to talk about a person's mental state in this capacity. I went back and I looked at the interactions on GitHub, and what you'll see there is that one is that this maintainer, in fact, has been doing the lion's share of the work continuously throughout the project. And then about a little less than 3 years, a little over 2 years ago, a new contributor came online and started contributing consistently. And if you look at those contributions, what you'll see is that most of them were the kind of contributions that I would have accepted on almost all of my projects, with the exception that this maintainer was a much more thorough reviewer than I was. Spent a lot more time reviewing these contributions. And then in our open source projects, we have often call them duocracies, and we have these pathways for onboarding new contributors. And this is how we sustain ourselves. It's our whole ethos. And this is exactly how it's supposed to work. Someone came in, they started doing small contributions, doc fixes, build fixes, CI fixes, starting to do more and more. And as they did that, the maintainer slowly elevated their privileges. And they consistently did almost no damage. And in fact, at this point, after the event, the maintainer's gone through and reviewed carefully each of those commits and commented on a log. And what you'll see is there's only 8 commits out of 451 commits. But all of those commits happened in basically the last month. And many of those commits were seemingly innocuous, and in fact, did nothing without an extra step that implicated other people beside the maintainer who's been blamed, who often, in many of these articles, is not named. His name, you can search through like all of the Red Hat documents, the name's not there. They just talked about the maintainer that's been burned out. If you look at the Red Hat response, and again, I'm not casting aspersions. I am a huge Red Hat booster. I use Red Hat software. I have certification. All of my computers run some flavor of Red Hat or Fedora, and I wouldn't choose any other operating system. But if you look at that blog post, you'll see things like this. InfoSec involved Red Hat's product security department. This global multidisciplinary team containing many of our finest developers, pen testers, offensive analysts, managers, directors, and program managers started their then confidential effort to properly establish, understand, and assess the findings from Andre. So they had numbers of people working on this. And so I decided, like, they must have obviously done some work on XC at this point, right? But no, not a single contribution. Instead, this overburdened, burned out maintainer started doing a lot more work. And these are just the commits. If you go through, he's done blog posts. He's been answering issues. He's been closing issues because people were just flooding the site after this media report with things like, oh, look at this. And then he's like, not that, stop this, get out of there. Another thing is that he's on his blog post, he specifically says that he won't answer media requests because he's too busy. He can't accept money because the Finnish government won't allow him without him providing services. And so he's had no voice in this and up to this day. And instead, he's just kept his nose to the grindstone, working very hard. Another thing is when we tell stories, there's the people who get to tell the stories, but there's also the people who create the names, right? And names are they're very powerful. That's why, like during COVID, there was a lot of discussion on what the virus was called. And there was aspersions for casting in certain names. And you'll see that on and on. So we call this incident, you'll see it everyone referred to as the XE incident. But you'll see embedded in this that XE itself wouldn't have done any of this. In fact, there's nothing on the GitHub repository that had that. What happened was that there was a few 8 commits with some binary blobs. There were test files that were committed to the repo. They've now been removed, but they were innocuous by themselves. And instead, there's a confluence of events. So one is that this person packaged it, and then they went to commercial companies largely, Red Hat, Debian, but that's downstream from Ubuntu. And there's several of those people on those teams that are being funded. They opened up bug reports and they had other people come on and escalate those issues and try to get the person to merge them. And they, in fact, found some issues with it. And so they were able to like make a patch that further hide what their attack was. So not only did they interact with this person, paid full-time developers, they reviewed it, they merged it, they gave feedback to help hide even more. And in fact, when I looked at it, I felt that the interactions that I saw with this sort of random person in Finland, who was this overburdened, burned out maintainer, what I saw was that he had done a much thorough job of vetting the code, seemed much less pressure to accept code. And in fact, they were even using them against each other, right? So they'd be like, oh, Fedora's doing this, so like Debian has to do this, or Debian has to do that, and Fedora did that. And then in fact, there's this thing called systemd. And if you go online, if you're a sysadmin like I was back in the day, you'll see that it was notoriously rejected and it caused a lot of upsetness with a lot of developers, as it was considered what you'll see phrases like security nightmare. And I'll show some slides, but you'll see in these articles, what happened was that this backdoor only works when SSH server is being run as a service by systemd. And that's because SSH by itself doesn't link to libraries that are patched by Red Hat and Debian by these paid developers. This library doesn't have any connection to OpenSSH except that everything's patched by systemd. And so you could check this out yourself. There's a huge discussion and all kinds of flame wars about systemd versus its predecessor init. I personally loved init. I was very sad when it went. Init had a very tight security model. It had a very small footprint. It was very easy to understand. It used a lot of very simple text files to configure. It was really easy to use and understand. I can tell you that. Systemd, I cost how it works. And I just took some things here, but the basic idea is that the complaints that developers have, and the developers, what I mean is the open source community, volunteer developer community, they'll say things like systemd contains a lot of unnecessary attack surface. It attempts to do far more things than necessary. It goes beyond what an init system should do. Centralization of control. Systemd has been criticized for centralized control over system and service management as a single powerful tool, a single point of failure. This is being developed by a commercial company, which is the one that I support quite a bit, and they're doing it on purpose, right? Because init was clunky for the sort of seamless desktop user experience you wanted. Like you had to actually know how to worked. It worked pretty easily, but it wasn't just plug and play. Everything just happens. You put a new device in, everything works like it's supposed to. And Red Hat's catering to its customers. In fact, if you go to Red Hat's mission, the very first part of who they serve is customers. That's very different than the UC system. When you go to UC system, its mission is teaching, research, and public service. The word customer does not appear. And so why is this the story we've heard? Well, the story is being told by a certain person, right? So in that same Red Hat response, they very clearly say what happened, right? They had our communication team fully engaged, informed, and ready. Minutes after the disclosure, they started receiving inquiries from major news outlets asking for more information. As we know, a lot of these mainstream media now are underfunded. They're competing very rapidly. They have fewer and fewer resources, and they're relying more and more on corporate communication teams to explain what's going on. And I think this is exactly the moment where the university hospitals and university academic with a public service mission, I think, have a role to play. So how can the UC system contribute to this story? So this is something that, as one of our OSPO activities as part of the UC OSPO network, we're interested in dealing with. It's personally a very compelling problem to me. I have this experience as a maintainer that I often have contributors coming in from all over the world. So for Network X, you'll have a maintainer come in, or not, sorry, just a random contribution from some country that you're not familiar with, who's at a university there. It may exist, may not exist, with affiliations and publications that I may or may not be aware of. And I have to look at what they do, and they say something that sounds like graph theory. It's a problem I don't understand, because there's many areas of graph theory. And so eventually I have to make a informed decision about trust that I think this looks right. And Network X seems like an academic project, but it turns out Network X is a graph analysis library, which graph analysis is something that compilers use. So there are compilers out there that are using this academic library in my mind. And I can very easily imagine this happening. The other thing, I had almost the week before this came out, I got a PR for another project I maintain that I never thought of as a security project. It's a small project called Lazy Loader. And it makes it so that you can import in Python lazily instead of greedily. And we're now using it in several things. So this changes the import mechanism of Python, which is how you load different libraries. And so after I realized that this could be a serious problem where you're actually changing how Python loads things. And there was a PR from someone who was active in the community. And when I looked at it, it was like changed lots of little things, and I just had to scan it. And I saw a URL that was very much, just from reading it, clearly an explicit URL. And I don't know how that happened. I happened to catch it, but it's very unlikely. It's very likely that I wouldn't have called that. And that wouldn't have been a big deal. It just would have been an explicit link, which I did not want in my project and didn't accept. But I can imagine like that kind of thing, if it's obfuscated, I would have missed. If it was malicious and obfuscated, I would have definitely missed it. There's I think really in the supply chain security thing, there's tools we need to build for people, but there's also, I think, social policy and other aspects we need to do. And that's, I think, again, what the university has, right? We have neuroscientists, we have psychologists that understand trust and reward and motivation. We have open source developers. I know that a lot of us talk about academic open source, but open source, started in academia largely, and was then now adopted by the technology sector. We have computer scientists, we have cybersecurity, we have AI. I can imagine we need some tooling to provide these overburdened maintainers tools to better analyze contributions. We also have journalism students, right? We have students that we can engage with and try to figure out how to tell the better, more full story. Because the story that was told is not a false one, it's just a perspective on the story. There's a much more complicated story that needs to be told. And these stories are important because policy makers at NSF, government, and in industry read these, and they make decisions on future bets and gambles and funding based on this. And so they need to have a more complete picture. We also have people in public policy and statistics. So we've written a small grant to form multidisciplinary, interdisciplinary multi-campus that includes UC Santa Cruz, UC Berkeley, UC San Diego. And we're going to try to organize meetings if that funding comes through. If not, we'll look for other funding sources to bring these groups together and start talking about this and trying to form a new research community that will be multiple disciplines and will really deal with this thing that I think is not just a huge implication for open source projects, but it has technology implications that run the California economy and the global economy in general. So pay attention, look at our OSPO site when it comes up. It's sort of up. Also, the blog, we will have a UC-wide blog, which will have an RSS feed, and we're going to be opening that up to the community. So once that's available, we love contributions, and we love these technology people to pay attention, and we will have tags and stuff. So I think that we can help, at least for the UC system, accelerate the sort of the transfer of knowledge and make sure we're all aware of this work. Thank you.
So to conclude, I just want to say this talk is an excuse for us to initiate a conversation about security in open source, which is something that a lot of people care about, but a lot of us don't know what to do. I think that these attack is a clear example of the fact that maybe we're not paying attention to everything that we need to be paying attention to, because as the stage is probably very highly guarded, there's security engineers that are paying attention about what gets in as the stage, but not like smaller packages, and huge threats can come from these smaller packages compromises. So yeah, I want to invite everyone to engage in these conversations that we're going to have here at the UC system. And yeah, we need to have more talks about security and start asking the right questions. Thank you.
Well, good question.
Hi, thanks for the presentation of from Linux Foundation. As you're speaking, I couldn't not think about the Stanford Internet Observatory that just shut down recently. And I'm wondering if you have any lessons learned. It's not the same thing, but I see some similarities. So especially you mentioned funding. So how do you plan to make that sustainable? Any ideas?
Yeah, it's a tough problem. I have probably for the last 12 years, I've only had like 1 to 2 years funding. I currently run out of funding in December 2025. This whole project that we're proposing is a UCOP proposal that would have, what was it, 150K? And it's split between 3 campuses. We're at 50K for each campus to do this effort. This summer, I wrote 6 grants between May and last Friday. And so I think what we're going to have to do is just like keep, working and trying to raise funds. If you're passionate about something, I think you just got to figure out how to make it happen. I think there's opportunities at Berkeley where we're going to be, bids where I work has sort of shrunk down, and we now have a new faculty director, and we're going to be doing a massive amount of, redirection and focusing. And I think you're going to see a lot of interesting stuff coming out of this. I think we also need to make sure that the federal funding agencies and have a very clear understanding of what they should be funding. So I think NASA right now has a really excellent understanding of open source funding. I think some of the other agencies have a partial understanding. And I think, again, one of my excitements of this UC-wide network is I think we can come together as a UC-wide group and have a statement where we can advocate for funding agencies to have a certain direction. And I think that's going to be a really powerful thing. The UC system is, not only huge, but we're probably, I think Berkeley often is like one of the largest organizational contributors to GitHub. And that includes Red Hat. And so, I think once we add in all the other UCs, like it's probably a lion's, the largest single entity contributions to GitHub right now. We're also like the home of Silicon Valley, right, nearby. So I think we're not only the right research institution, I think the right place for this. And so I think we need to, one is just working, writing grants, trying to find funding opportunities, but I think we also need to help the federal agencies and foundations understand what the right funding model is. Also, industry, I think, needs to have some role in this. I know asking for money is not the right thing, but I hope that if we have this sort of these meetings, that we can invite some industry people and have them participate as well. I think there's a lot of complicated things, and I don't mean to say, like again, I love Red Hat. I think Red Hat did an amazing job. I think System D is probably a really amazing piece of technology, a little bit old, so I like the old stuff. I still use it. But maybe Emacs one day will be good enough. I don't know. But yeah, so I think it's a hard problem, and I think it's just going to have to keep working.
So I guess my question is not just to you, but anybody in the room who cares about security in open source space. Are there any best practices in terms of handling, like there's finding a security flaw and there's closing the loop, right? So are there any best practices in terms of handling CVEs in open source projects?
Yeah, so I think it's a mixed bag. Like I think it's very likely it's the open source that has industry funding or serious support, with the Linux Foundation, probably have a very clear case. A lot of the projects I'm involved with have not had funding historically, and when we've had CVE reports, they've often been just noise, and we just close them after looking at them. But that's something that I think is going to be an increasingly growing problem. And I also worry a lot about the generative AI because, like, again, one of the ways I figure out whether I trust someone is I look at if what they're giving me looks like reasonable code. I look at what they're saying, and does it sound like they know what network analysis is? And I have been using some of this generative AI, and it, with some prompting, it can sound like it knows what it's talking about. And I think that's only going to get better. And so I think that, the deluge is going to get more and more. And I think that, the risk of the state actors is prevalent and continuing, but I think it's also going to be a lot easier for smaller outfits to do a 2-year exploit, 3-year exploit. So I think it's a dangerous role we're getting into. And I think it's going to require, an all hands approach. And I think it's going to be interesting frontier times.
So I've talked to a couple of maintainers, because this is actually part of my research, is how do we get better tooling and metrics for open source maintainers to handle security better. And I think one of the problems is that maintainers are not necessarily experts in security. So when an open source maintainer gets a report in their package, it's like, what do I do? Like, I don't know anything about security. I don't know if this actually affects my package. And there is very little help from other entities that do have this expertise for these maintainers to actually decide what to do with a CVE. Starting from what do we do? Should I make it public? Like, how do I even share it with the community? Is this actually a security breach? So this is one of the biggest challenges, is how do we make how do we help maintainers with security without actually them being experts in security? So yeah, just want to say that.
Well, I think some of the common practices are to have like a security MD as part of your project, which basically says what is your security posture essentially, and have a private list in case there's security to report it over there, not file as a public data issue. Because CVEs, you don't know how it's going to impact them, who's going to exploit. As much as there are good actors, there are bad actors as well. The other thing, within Intel, we have about 100,000 plus internal repos. And one thing we run over there is the OpenSSF scorecard. And OpenSSF, the whole mission of the foundation is to improve the security posture in open source. And that scorecard gives you a rating from 0 to 10. And top-notch projects are like 9.8 kind of rating. And what the idea is not where you are, but idea is not where you are, but idea is to do that incremental improvement. So for example, we started with a certain base score, And then we targeted that we're gonna improve that score by 10% in the next 6 months, and basically start monitoring across 100,000 repos. What's the scorecard report also tells you what are the challenges in your project, why it is not secure. So CVE is just part of the problem. It may tell you like we use GitHub Dependabot pretty extensively for CVE management. So I think those are some of the standard industry practices that we have seen across the board that we use at inter-managed projects.
Yeah, I agree. They were nice tools. My experience with them has been they've been mostly noise. I've started turning Dependabot down because it's been breaking things quite a bit. It uploads, it changes your artifact uploader to version 4, and 3 allows you to like do globs, 4 doesn't. And so now when I run my release, it doesn't work. And so I've manually been doing things much more. But yeah, and then security MD, I have those in my projects. I haven't ever had a security report on any project I've worked on through that mechanism. I've had a couple there's a couple companies like Synopsys or something that send me stuff to open up issues every once in a while, but those are typically things like, Python's an interpreted language. You're like, yeah, I know. Close. Maybe it's something exaggerated, but it's stuff that's like, really not appropriate. And so I think that these are nice tools, but I think part of what I want to do is figure out how we go to the next level of that. Because I think, even with the scorecard thing, I think it's had problems finding things like licenses and it's license.txt or license. It's like stuff where it's like, if it's just a little different, it's a little brittle. And I think some of these LLMs, I think the next generation of that scorecard, I think could have a lot more impact. I've also run, which I think was the scorecard gave me, was some of these automated security detection things. And they've been not amazingly helpful, but then I did have a couple things that have been useful that I didn't know about. So it's getting better.
So I actually did an experiment so I'm part of the security committee of Focus, which is fiscal sponsor for a bunch of scientific Python open source projects and other non-Python projects too. And I actually did the experiment of running scorecard in all of the projects and talking to maintainers about their scorecard results, because a lot of the projects didn't have a very high score. And the conversation that I was having was like, how do you feel about this? And does this mean something for you? And a lot of the responses were very similar to what Jarrod is saying is, yeah, we are aware that Dependabot exists, but we don't want to use it because it doesn't give me the information that I want and it becomes some noise. And a lot of the things that scorecard measures happen to be the same. And it's more about the fact that the metrics are too general sometimes. And for example, a lot of Python maintainers were like, I don't think fuzzing I don't think we should use fuzzing. I don't think we need fuzzing. And I think that is kind of the problem where, yeah, there is a bunch of tools, but I don't think they're necessarily targeted to your specific package. I do like scorecards, and a good thing that I heard about scorecards was maybe I don't pay attention too much to the number itself, but it does give me some kind of summary of the things that are good to measure in a project, right? Like some things like, oh, I should have a security policy in my repository. I didn't know about this. So a lot of maintainers were like, yeah, I don't think the score is actually useful because a lot of these things maybe don't apply, but it does kind of help project maintainers be aware of some of the things that they should be paying attention to.
Thanks very much.
Thank you.